I'm really happy and excited to be here to talk to you about algae. And it's funny because my kids say that I can take any conversation and turn it around so that I'm talking about algae. So I was sitting on the side over there thinking about how can I turn this box of cookies into a story about algae. I'm not gonna go into that, but probably could. So why am I so excited about algae? First of all, you've got to say, what is algae? Algae is just a huge opportunity, and there are thought to be at least 800,000 different species of algae. So that is a large number of different types of algae. And they are truly very different. If you think about it, they found algae in the sand out in the desert. They found algae on ice caps, so growing, in very cold weather. Algae can grow sometimes in really high salt water, can grow in fresh water, it can grow on waste products, so extremely diverse. And there have been 15,000 novel compounds that have been found in algae. So what are the opportunities there? I mean, there's so many different things. And also we know that how you grow the algae, how you feed the algae can change it and make it even more different. So if you look at, I'm saying there's all these different types of algae. If I'm saying that I have a type of algae, that would be like saying I have a plant. It doesn't give you any information because the composition can be so different. You can have algae that's very high in protein, as high as 40 to 60% protein. So you can have an algae that you could use as a very good protein source. You can also have algae that's high in oil or fat. That's why so many people have been looking at it as, can we grow an algae and extract the oil for biofuel? And so used to, this slide would have said 2 to 50% is what you could expect for the oil in algae. But we are producing an algae now that's 70% oil, so very, very high oil. You can also have algae that's high in carbohydrates. There's other types of algae that can be high in different types of pigments, different types of vitamins, minerals. So there's so many different options that we would naturally find in different types of algae. And then again, we can change that composition by the way we grow it or by the nutrients that we feed it. So when I say the way we grow algae, there's two different ways to grow algae. And the first one is autotrophic, and that is what you normally would think about if you think about algae. So if you think about algae that's growing out on a pond or a river, or maybe in your fish tank, that would be autotrophic algae or photosynthetic. So it's growing very much like you would grow a plant. So it's taking in carbon dioxide, breaking that bond, and using the carbon as its sugar source or carbon source, and letting off oxygen. So that is what you see in this picture, different methods of growing autotrophic algae. Now, there's some advantages to growing it this way. Cost is typically considered to be cheap because you're using just natural sunlight and carbon dioxide to grow it. But there's also some very big disadvantages. If you look at this, you're you have to depend on whatever your environmental conditions are. So if it's extremely hot, you have to have an algae that'll grow under those conditions. If it's extremely cold, you have to have an algae that would grow under cold conditions. What if your temperature fluctuates a lot? We tried to grow some algae this way in Kentucky, and our temperature might drop 30 degrees at night. And so algae that would grow during the day would suddenly all die at night or not grow well, and then some other contaminant, bacteria or algae, might grow under those conditions. So keeping a pure culture was extremely difficult. You also have to worry about any other types of animals or other types of contaminants that you would get when you have it in an open system. Also, since photosynthesis is so important, if you look at the bags, as soon as you get some algae start to grow, it'll block the sunlight. So then you're done. So it's not very efficient. You get very low levels of algae growth when you do it this way. So there are some problems. Traceability is a problem. How do you downstream process it if you've got it in a raceway? So there are negatives to this type of system. The other way that we can grow algae is called heterotrophic algae, and that's what you see here. In this case, we're growing it almost like you would grow a yeast. So in a very large closed fermenter, as you can see, there would be no sunlight. So if there's no sunlight, we don't get photosynthesis. So we have to actually feed it the carbon source. So it's a little bit different. But the big advantages to this is that it's very highly controlled. So you can see, if you look at this small fermenter down here, everything's all hooked up. That means we're controlling the temperature, we're controlling the pH, we're controlling the mixing speed, we're also controlling what nutrients we feed it. So when we do this, we can have a very highly sterile system. We can grow pure culture, so we don't have to worry about contaminants. And we can also get very high efficiency. So you can get very high levels of the algae because you're continuing to feed it. And with this is how we have accomplished getting the 70% fat that I had mentioned earlier, is because we're going through a very controlled system. This is our Alltech algae facility in Kentucky. So you can see up in the top of the large window, you can see some of the fermenters there. So they're very large. And at that facility, I mentioned that we were producing an algae that was 70% fat. But the important part about that is that it's a high DHA algae. So of that fat, up to 30% of the fat would be DHA. So very high levels of DHA. So what is DHA? It is an omega-3 fatty acid. So it is one of the omega-3 fatty acids. It's often called a good fat. So you might have heard that a lot of times you were told by doctors to eat a low-fat diet. And that's kind of changed now. Now they're telling you to eat a good fat diet. Well, what does that mean? Do people know what a good fat is? Well, this is what a good fat is, DHA. So if you go back again to looking at fatty acids, so at the top you've got your fatty acids, breaks down into saturated and unsaturated fatty acids. If you go on down under the unsaturated fatty acids, you have omega-6 fatty acids. Those typically come from your vegetable grain sources. And then you have the omega-3 fatty acids. So under omega-3 fatty acids, there's a variety of fatty acids, but the three that are very important are the ALA, EPA, and DHA. So those are three of what is under the category of omega-3. So let's talk about those, because everybody hears, okay, this is an omega-3 product, but all omega-3 fatty acids are not the same. So when we talk about ALA, that is the most common one that you would see out in products that are omega-3. That comes typically from things like flax or linseed. And the value of it is that it's a source of energy. But the main value for ALA is that it can convert to DHA in the human body. Now that conversion is very inefficient. It depends on whether you're male or female, how old you are, what your diet is, what your health condition is, but it's typically only about 5 to 10%. So pretty low, so you really have to take in a lot of ALA to get what you're really wanting, which is DHA. The second one on the list is EPA, and EPA comes typically from fish sources. Also, as I'd mentioned, you can convert from ALA to EPA. You can also convert from EPA on down to DHA. That conversion's a little bit better, but it's still only about 20 to 23%. Then we have DHA. And again, that is the omega-3 that we're really looking for in our diet. It's very important for brain and eye development. It's very important for heart health and very important for immunity. So there's a lot of value to DHA. Again, DHA cannot be synthesized in vertebrates. We have to get it in our diet. So where does it come from? Typically, you would get DHA from fish or fish products. So in our case, from fish, fatty fish. And if we're feeding animals, it's going to come from things like fish meal and fish oil. Now, we know there's a lot of problems right now with that, typically with sustainability. The amount of fish and fish oil that's being produced is pretty much at a certain level. They're trying to produce more and more fish for aquaculture, limited very much by the amount of fish meal and fish oil that's out there. So sustainability is an issue. The other issue is a lot of times you hear about contaminants in seafood and in fish products. So those would be things like heavy metals, dioxins, PCBs. So there are a lot of issues that you have to consider if you're trying to take in a lot of fish to get your DHA. The other sources of DHA are algae, or also animal products that have had DHA in their diet. So if we look at this and we say, okay, where do fish get the DHA? Do they synthesize it? And no, they don't. They actually get it from the fact that you start with algae in the ocean, and then crustaceans eat the algae, and then you have small fish that eat it, and then larger fish. So it really all originates from the algae. So what we're doing is we're just taking that same algae and kind of bypassing the fish and growing it ourselves to get DHA. So we're going all the way back to the source, which is algae, to produce our DHA. So then what is the importance of DHA in human diets? This is not anything that's new, because if you would look at almost all infant formulas will have DHA added to them. Prenatal vitamins have DHA. And that's because we realize that DHA is very, very necessary for eye and brain development in babies. So you would put it in the prenatal vitamins so that it would come through the mother as the baby was growing, and then it would go into the infant formula. So very, very well known and documented on that. But what happens when that child comes off of their infant formula? So I would imagine a lot of you have children or know children, and most 3-year-olds probably don't like to eat fish a whole lot, or fatty fish. And that's, as I've said, the main source of DHA in our diet. So if you look at the recommended daily level of DHA that a 3-year-old should get, it's about 150 milligrams per day. But the average consumption for a 3-year-old is 19 milligrams per day. So way, way under. And we all know that the brain and eyes are probably not fully developed at a 3-year-old. The brain is definitely not. The brain is actually in stages where a child is still really learning a lot. So deficiency of DHA has now been linked to a lot of things, such as deficiency, ADHD and ADD, learning disorders. So there's a whole lot of work that's going on as far as supplementing DHA to help with children. So it's a really interesting area. What about adults? Coronary heart disease is one of the main killers, and it doesn't distinguish between men and women. This map is from 2002, but just shows you kind of the different areas. So you can see the really dark ones are the highest levels or highest deaths from coronary heart disease. And again, if we talk about DHA, with the American Heart Association, and actually most of the heart associations around the world, what they recommend is for somebody with coronary heart disease that they would get up to 1 gram or 1,000 milligrams of EPA and DHA per day. And then for everybody else, we should be eating a healthy diet, which is 2 servings of a fatty fish per week. So are we all doing that? That's the question. And if you look at this, this is showing the level of where we should be with getting the EPA and DHA. So that level is right up here at the 250 milligrams per day. And then if you look down here, this is where we actually are. What this is showing is male and female, and across the bottom is male and female in different age groups. But you can see even at the best, we're really probably only at about half the level of DHA that we should be getting each day. So that does have a big effect on our heart health, but also our brain health. There have been recent studies where they have looked at the brain size. They've done MRIs of elderly people and looked at the size of their brain. And then they would measure the DHA in their bloodstream. And there was a very nice correlation between the people with the larger brain capacity or size had the higher levels of DHA. We all know as we age, our brain does start to shrink. So this was just the first step on looking at the size of the brain and linking it to the DHA in the blood. They're now going those next steps to say, what does that really tell us? But all very interesting things for us. So we are looking at, again, if you have such a deficiency and people are not eating the seafood they should, what are the opportunities for us? So if you look at and say, well, we're producing a high-fat algae that's high in DHA, yes, you could go straight into the food side, or you could go over here to the animals. And you could feed it because animals are going to get the same benefit. It's also an essential fatty acid for animals. So it would help in animal health, as well as would it enrich the meat, the milk, the eggs, and give us then something that goes into the food chain for humans. Well, we started this, we've done it with eggs, we've done it with broilers, we've done it with pigs, so we've done it and we can show the animal benefit as well as that it does enrich the meat and the eggs. But what about with ruminants? Because that's what we care about here. So we started out with looking at our algae and a supplementation in late lactation dairy cows. And what we saw initially on the performance side was that we had an extra 1.9 kilos per head per day over the whole course of the trial. What you can really see if you look out towards the end is that we're getting very nice persistency. We're not having the drop off. And it was consistent that it was always higher. We did have some days and periods that we went up as high as 4 kilos, but over the whole time it was right around 2 kilos per head per day. But then here was the interesting thing. We weren't just seeing a DHA shift. We were seeing significant shifts kind of across the board. So the star shows that these are significant numbers. And so we saw that the saturated fatty acid in the milk went down, the unsaturated fatty acid went up, and then we saw the two on the other side are the highly unsaturated fatty acids. Interestingly, we saw a very large increase, significant increase in conjugated linolenic acid, so CLA. That was interesting to us because we weren't adding any CLA in the algae, we were not adding a precursor, so what we're showing is that we were really shifting things as far as the health. We see a significant increase in the DHA, in total omega-3s, and then this ratio at the end where we're showing that we're really decreasing that omega-6 to omega-3 ratio is extremely important also because there have been lots of work done that in early days that ratio of omega-6 to omega-3 in human diets was about 1-to-1 ratio. And right now in a Western diet, it's up to about 16-to-1. So that's a very large shift of the ratio, which it's understandable. We're eating a lot more grains. We're eating things that are from processed, from sugar. Our animals are eating a lot more DDG. If you look at even seafood diets, when they're feeding aquaculture, they're making shifts from fish meal and fish oil to vegetable meals. So all of these things are putting more and more omega-6 into our diet. So having that real high ratio has been linked to a lot of diseases, and reducing that ratio is very good for human health. So again, we're showing that here. So what we're seeing is by feeding the cow the algae that's high in DHA, we're not just adding DHA to the milk. We're completely changing the whole composition of that milk to a healthier milk. So that was very exciting for us. So then what are we doing next with this? Dr. Lyons had mentioned fertility, and we have seen some things on commercial levels that are very interesting. So what we're doing right now is a full reproduction trial that's ongoing, will be complete here soon at the University of Florida. So that is the next thing that we're looking at on the dairy side. What are our opportunities in beef cattle? So this was another area we're looking at. And people are always saying, how can we get more value out of our milk, out of our meat? And branding is a good way to do that. And you don't see as much branded meat, but you're starting to see it, and it's a real opportunity to separate yourself out. So we've done a trial at Kansas State University. We are expecting the final report soon to give the statistics, but we do have the early numbers. And it's quite interesting because what you will see is this was performance at 88 days before slaughter. And so initial weight was right around 454 kilos in all groups. We had a control, 50 gram per head per day, 100 gram per head per day, and 150. So that's how much algae we were adding. You'll notice at 64 days, we saw very nice increases in average daily gain. So in the control, it was 755 grams per day, and then it went up to 877, 855, and at 150 grams of algae per day, we saw a very nice increase on the average daily gain. When you look at 88 days, the control kind of caught up, so it evens out a little bit, but we still see a nice increase. And then if you look at dry matter intake and then gain to feed, you can see nice values here. So this was interesting that we saw. What we were really looking at is, could we get enrichment of the meat with DHA? But we're seeing some very interesting things on the performance side. Typically, when we're looking at DHA in meat, you're looking at the high value cuts, and we see that with steaks and different things. But then you always wonder, what are you going to do with the other part of the meat? You know, you're going to spend extra money to put this program together, and then you're going to have all this, in this case, ground beef that wouldn't have a value. But what we're seeing here is a very nice value to the ground beef. So if you look at that, you will see that you have kind of a linear effect. So the more algae that you're feeding to it, the more DHA that you get in the ground beef. So this is showing exactly what we were looking for and what we were expecting. And again, if you think outside the box and you're thinking the value of this, when we're showing that children and grown-ups are not getting enough DHA in their diet, they're not eating the amount of seafood they should, is there an opportunity for this with beef and with milk? So with this, what we saw again is that we're getting a positive effect on the performance side. With the omega-3s, it says shorter feeding time, because what we found is you really only have to feed it for about the last 28 days. So we can reduce that feeding time towards the end. And that we're looking at value in all parts of the meat. So with this, what we're seeing is that we can really change the health of the animal and change the value of the final product that we're going to get, which is going to be very valuable to the health for the humans. So thank you.